So today I'll be talking about remainder theorem, right? And very often when we learn remainder theorem, we're told to actually set the divisor to 0 and solve for the x, and then substitute this into the polynomial fx, and then somehow that's going to miraculously give us the remainder without doing so much work as long division. All right. So today I'll be examining the reason why there is a basis for doing that, and I'll be taking you through the concept of that as well. Alright, so let's say we have a polynomial fx, and let's say fx equals to 2x squared plus 5x minus 4, as you see on your screen. And then we have a linear divisor, ax minus b. Linear meaning is x to the power 1, and then we have a and b where it could be some integer. So for example, divisor is x minus 3. Alright, and we aim to find the remainder. So this itself, you would find it very similar to another video that I've done where I divide 2x squared plus 5x minus 4 by x minus 3, and I get a remainder of 29. So if we actually want to only find the remainder, we don't actually have to do so much work, alright, as the long division. Of course, the long division has other uses, but we don't have to do that if we just want to know the remainder. Alright, so in here the fx is the 2x squared plus 5x minus 4, and then the linear divisor ax minus b is in this case the x minus 3, and then of course we times the quotient, which is in here the 2x plus 11, and then the remainder, which is the 29. Alright, so for us, if we want to just find the remainder, alright, we just need to find a value of x to sub in, whereby the whole entire divisor times quotient will just become 0. So when that becomes 0, I'm going to be only left with the r. So that's what we set out to do. Alright, so I'm just going to remove all this. Alright, so specifically, to make divisor times quotient become 0, it is essentially just making the divisor become 0. And so therefore, to get the r, basically we set the divisor ax minus b equals to 0. Alright, and therefore x equals to b over a. And so therefore we will substitute x equals to b over a into fx. Alright, so we will get f of b over a equals to a times b over a, which is x, minus b times qx, where q is q of b over a, which is not really important because we will get the 0 anyway, then plus the r. Alright, so since a and a cancels here, what happens is we'll have b minus b, which is just going to give us 0. Alright, so this is actually 0 times the quotient when we sub in b over a as the x plus r, and therefore we'll be left with r. So that's how you will be told to substitute, right, x equals to b over a into f of x in order for you to get f of b over a equals to remainder r, and this is the remainder theorem. Thanks for watching this video. Alright, I hope this helps you to understand why you need to sub in x equals to b over a, and somehow that gives you the remainder, and using that factor theorem will be a special case where the remainder turns out to be 0. So it's similar concept as well. So have fun with doing maths, and until the next video, goodbye.